Okay, so we're going live. Going live. We'll start at 8 a.m. I forgot how to talk over the weekend. Jessica Becker, Mariana Butler, Damon Clinton, Austin Cook, Hi Dane, Jose Favela, Brianna, Bo Hepworth, Isabella Holt, Scott.
Hotelin.
How do you say that?
Hotelin.
Hotelin?
Yes.
I'll just say Scott.
Yes. I spent 6 years in the service. I've heard everything in between.
Marcos Lopez, Howie Nicholson. Okay, Zach Peters. Yeah, if you're online, you can go ahead and sign in. We'll start in a minute. Hey, it's 8 o'clock. We'll be in section 3.1 again. We'll learn more about graphing linear equations, but today we'll include the X and Y intercepts when graphing. Okay, so we start out with this statement. Every straight line in the XY plane that is not vertical and not horizontal will intersect the x-axis at exactly one point, and it also intersects the y-axis at exactly one point. The x-intercept of a line is the point on the x-axis where the line intersects, and the y-intercept of a line is the point on the y-axis where the line intersects. So that makes sense. The term itself explains what it is. X-intercept, that's a point on the x-axis where the line touches or crosses or intersects, and then the y-intercept is a point on the y-axis where the line intersects. Last week, we noted that every x-intercept has a y-coordinate that is 0. And every y-intercept has an x-coordinate that is 0. So in this example, graph the equation negative 2x minus 4y equals negative 4 by plotting the intercepts. By that, it is meant x and y intercepts. Okay, so first we'll find the x and y intercepts. Then we'll plot the ordered pairs that are the x and y intercepts in the xy plane. So I'm creating a table for the x and y coordinates, and then afterwards we'll more formally identify them as ordered pairs, x comma y in parentheses. Okay, so if I want to find the y-intercept, what should I do? I pick x to be 0 because every y-intercept has an x-coordinate that is equal to 0. That's one of our two statements up here. Every y-intercept has an x-coordinate that is 0. So in the equation, we replace x with 0 and do the arithmetic to find the corresponding y-coordinate. Okay, so in this equation, looks like my page is out of kilter here. All right, straighten the camera a little bit. Okay, so in this equation, replace x with 0. We get negative 2 times 0 minus 4y equals negative 4. Or negative 4 equals negative 4. Negative 4y equals negative 4. And then divide both sides by negative 4, we get y equals 1. So when x is 0, the y-coordinate is 1. So we have the ordered pair 0, 1. That is the y-intercept. Okay, so down here, let's find the x-intercept. What's true about every x-intercept? Well, for an x-intercept, the y-coordinate is 0. So this time in the equation, we replace y with 0. So when we replace y with 0, we'll just get negative 2x equals negative 4. And then divide both sides by negative 2, we get x equals 2. Okay, so when y is 0, the x coordinate is 2. The ordered pair 2, 0 is the x-intercept. Okay, so now we can sketch a graph of this equation, this linear equation in two variables, x and y. So we plot the y-intercept, 0, 1. So we'll label the point 0, 1. Plot the x-intercept, 2, 0. 2, 0, that's the x-intercept. And then we can draw a straight line through those 2 points. Okay, it's not the only way to graph a linear equation in the variables x and y, but it's a pretty convenient method because in the first case, replacing x with 0, that term involving x is 0, so we can ignore it, and then we can easily solve for y. And then to find the x-intercept, just replace y with 0, and you get a simple equation to solve for x. So it's a very nice method when it works. So the next one, let's do the same thing. Graph the equation y equals x divided by 2 minus 3 by plotting the intercepts. So we'll find the x and y intercepts. Okay, so let's find the y-intercept first. When x is 0, we can do some of this in our head. When x is 0, we get y equals 0 divided by 2 minus 3, which is 0 minus 3, and 0 minus 3 is negative 3. So the y-intercept is the ordered pair 0, negative 3. Okay, then to find the x-intercept, first I'll label this just to remind you. This first ordered pair is the y-intercept. It has an x-coordinate that's equal to 0, so it's the y-intercept. To find the x-intercept, this time we replace y with 0 and solve for x. Okay, this one's a little more involved. So in the equation, replace y with 0. So we get 0 equals x divided by 2 minus 3. And then we solve this for x. We can add 3 to both sides to start with. And we get 3 equals x divided by 2. And then if we multiply both sides by 2, so on the left, 2 times 3 equals, on the right, 2 times x divided by 2. And we get 6 equals x. So the x-coordinate of the x-intercept is 6. The ordered pair 6, 0 is the x-intercept. Okay, so we can graph the line by plotting those two ordered pairs. So 0, negative 3, and 6, 0. So label the points. This one is 0, -3. And this one is 6, 0. And then draw a straight line through those points. Okay, so the horizontal axis is the x-axis, the vertical axis is the y-axis. Okay, so the next one is just more of the same. Graph the equation -3x minus 2y equals 6 by plotting the intercepts, the x and y intercepts. Hey, this one won't take long. If we find the y-intercept first, the x-coordinate is 0. So in the equation, replace x with 0. We get -3 times 0 minus 2y equals 6. Or -2y equals 6 and y equals -3. Okay, so the y-intercept is the ordered pair 0 for x, -3 for y. Then to find the x-intercept, we replace we replace y with 0. To find the x-intercept, replace y with 0. So this time we have -3x minus 2 times 0 equals 6. Or -3x equals 6. Divide both sides by -3, we get x equals -2. Okay, so the ordered pair -2, 0 is the x-intercept. Okay, then we can plot those 2 points. 0, -3, -2, 0. Okay, this one is 0, -3. The other point is -2, 0. And then draw a straight line through those 2 points. Okay, that's all there is to it. You'll encounter equations where the arithmetic is more challenging. So we sort of saw that in this second example up here. It wasn't too bad, but work on the arithmetic if you have difficulty with that. That's one of the skills that you'll want to develop in this class. Okay, so that pretty much covers section 3.1. So what I want to do is I want to look at some of the absolute value inequality problems from chapter 2, section 7, part B. We didn't have time to cover these the other day, a few days ago. But absolute value inequalities seem to be something of a challenge. So this first one, the absolute value of 2x minus 5 is less than or equal to 3. Okay, think about what that means. If the absolute value of a number is less than or equal to 3, that means that number has to stay pretty close to 0 because its distance from 0 is less than or equal to 3. So graphically, the numbers of the form 2x minus 5, those numbers of that form 2x minus 5, they have to be between -3 and 3. So -3 has to be less than or equal to 2x minus 5, which is less than or equal to +3. So this is the compound inequality implied by the absolute value inequality. So just think of 2x minus 5 as a number. So if I remove the absolute value symbols, since the distance that number is from 0 is less than or equal to 3, then the farthest to the right that 2x minus 5 can get is 3. And the farthest to the left 2x minus 5 can get is -3, right? It can't break out on either side. It has to stay between 3 and -3. That's what this is telling us. Okay, we do want to solve this inequality for x. So I'll rewrite that, and then we'll get x by itself in the middle. Okay, so we're going to work on all 3 parts of that. We have to do the same thing to all 3 parts. The first thing we'll do is we'll add 5 to each of the 3 parts to preserve the inequalities. So -3 plus 5 is 2. And in the middle, 2x minus 5 plus 5 is 2x. And on the right, 3 plus 5 is 8. And then the next step, divide each of the 3 parts by 2. 2 divided by 2 is 1. 2x divided by 2 is x. 8 divided by 2 is 4. Okay, so this is the algebraic notation for the solution set. Algebraic notation. The word and is implied, but we don't write the word and in this case. We can use the word and when we read this. When we read this, we could say 1 is less than or equal to x, and x is less than or equal to 4. The word and means that x satisfies 2 conditions at the same time. Not only is x greater than or equal to 1, but x must also be less than or equal to 4. Okay, the same set in interval notation is bracket 1 comma 4 bracket. This is the interval notation for the exact same set of numbers. Interval notation. Okay, so these 2 sets of numbers are the exact same set of numbers, just 2 different notations. The algebraic notation involves the variable, x in this case. The interval notation doesn't involve the variable. Okay, the next absolute value inequality is different than the one we just did. This time we have the absolute value of 6x plus 5 is greater than 7. So 6x plus 5 just represents a number. And if the absolute value of a number is greater than 7, then that number can't get closer to 0 than 7. That number either has to be from 7 and to the right, or from negative 7 and to the left. Right? If the distance a number is from 0 is greater than 7, then that number cannot get close to 0. It can only get so close. So if we plot the numbers 0, 7, and negative 7, then the numbers that have the form 6x plus 5 have to be less than negative 7, or 6x plus 5 has to be greater than positive 7. See what I mean? If the distance of a number is from 0 is greater than 7, well, that number could be to the right of 7 on the number line, or that number could be to the left of negative 7. That number cannot get any closer to 0 than in one of those two sets. But since those two parts of the number line are separated by an interval, we use the word or, because a number can only be in one of those two places at once. So either that number that has the form 6x plus 5 is in this part of the number line on the left, or it's in this part of the number line on the right. That's why we use the word or. Okay, we want to solve for x, but this is a good start. If you can get this far, then we just solve each of those compound inequalities separately. But we'll do them together, and we'll separate the two inequalities with the word or. So the first step is to subtract 5 from both sides. So on the left, when we subtract 5, we'll get 6x is less than negative 12. Then write the word or, and then on the right-hand side, we'll also solve for x. So when we subtract 5 from this one, we get 6x is greater than 2. And then in the next step, we will have the complete algebraic notation. If 6x is less than negative 12, we divide both sides by 6. We get x is less than negative 2. Then write the word or. If 6x is greater than 2, divide both sides by 6, we get x is greater than 2 over 6, or 1/3. Hey, this is the algebraic notation. In this case, when we use the algebraic notation, we write the word or. Okay, so this is our answer for the algebraic notation. We can sketch a graph of this x is less than negative 2 or x is greater than 1/3. It will look similar to this graph because This compound inequality produced this one when we solved it for x. So we plot the numbers -2 and 1 and 1/3, 1/3. Okay, so if x is less than -2, on the number line, we put a parenthesis that opens to the left, and then we color the line to the left of -2. Or x is greater than 1/3, we put a parenthesis at 1/3 and shade to the right. Okay, so remember in interval notation, the word or translates to the union symbol. Union means we're combining both parts of the number line together so that we get a bigger set than the individual sets. Okay, this number line, or this part of the solution on the left, this is from -infinity to -2. So on the left, we write parenthesis, -infinity, comma, -2 parenthesis, union. And the other part of the number line, parenthesis, 1/3, comma, infinity, parenthesis. This is the interval notation. Okay, so two of the absolute value inequalities that you'll want to make sure that you get a handle on are like these two examples. There are some other ones that are sort of, you need to know how to do the other ones too. You know, for example, we saw some cases where inequalities led to no solution or the empty set. And in other cases, the solutions was the set of all real numbers from -infinity to +infinity. Hey, but if you learn how to analyze and think about what you're looking at, you should be able to determine what it is that you're going to get for a solution. Okay, let's try this one. The absolute value of 5y plus 2 plus 4 is less than 13. The first thing to do on this one is to get this into standard form, which means that we want the absolute value of 5y plus 2 by itself. So first thing, subtract 4 from both sides, and we get the absolute value of 5y plus 2 is less than 9. Okay, let's think about what this means. Just think of 5y plus 2 as a number. If the absolute value of a number is less than 9, then the distance from 0 that number has to be less than 9. So it can't get very far away. So if the distance a number is from 0 is less than 9, then that number has to be between -9 and +9. So this is the compound inequality that we get. This compound inequality no longer has the absolute value symbols, so make sure you notice that. Okay, but this is what the inequality is telling us. We want to solve for y, so just like we did before, -9 is less than 5y plus 2, and 5y plus 2 is less than 9. So we use the word and, but we don't write the word and. We can read the word and. So to solve for y, we subtract 2 from each of the 3 parts. -9 minus 2 is -11. That's less than 5y plus 2 minus 2, which is less than 5y, and that's less than 9 minus 2, which is less than 7. And then we divide all 3 parts by 5. So -11 fifths is less than 5y divided by 5, which is less than y. Less than 7 divided by 5 is less than 7 fifths. Okay, that is the algebraic notation. It involves the variable y. And then the interval notation, well, since the inequality is strictly less in both cases, we use a parenthesis, -11 fifths, comma, 7 fifths, comma. This is the interval notation for the same set. I guess we can go ahead and graph this just to reinforce the concept. So we plot the numbers -11 fifths and +7 fifths. And just the numbers between -11 fifths and 7 fifths. So that's the graph of the solution set. Okay, so I'll repeat myself again because repetition is the key to learning. Each one of these 3 representations means exactly the same thing as the other 2. So the graph of the solution set, that communicates the exact same information as the interval notation, and each of those communicates exactly the same information as the algebraic notation. Each one of those 3 is equivalent to the other 2, just in a different format. Okay, the next one, 3 times the absolute value of 4y minus 3 is greater than or equal to 15. In this one, we want to start by dividing both sides by 3. So we'll divide both sides by 3, and we get the absolute value of 4y minus 3 is greater than or equal to 5. Okay, so 4y minus 3 just represents a number. If the absolute value of a number is greater than or equal to 5, then that number must not get closer than 5 from either side, or it can't. So if we plot the numbers 5 and -5, then the numbers that have an absolute value greater than or equal to 5, well, those numbers, 4y minus 3 is less than or equal to -5, or 4y minus 3 is greater than or equal to +5. So graphically, they are either from -5 and to the left, or they are from +5 and to the right. So that's supposed to be a 4y. Okay, if this is making sense, then that is a good sign. This time we use the word or we write the word or, and then we're going to solve for y. Okay, so I'll rewrite that part. So we write 4y minus 3 is less than or equal to negative 5, or 4y minus 3 is greater than or equal to positive 5. And then we'll solve each of those two inequalities together, and we'll separate the results by using the word or each time. So we add 3 to both sides. We get 4y is less than or equal to negative 2, or, and then when we add 3 to both sides of this, we get 4y is greater than or equal to 8. And then divide both sides by 4. 4y is less than or equal to negative 2, so y is less than or equal to negative 1/2. Or 4y greater than or equal to 8. When we divide both sides by 4, we get y is greater than or equal to 2. Okay, so that is the algebraic notation. The word or is used in this compound inequality. Okay, the interval notation, y less than or equal to negative 1/2, that's negative infinity, comma, negative 1/2, bracket. The word or is represented by the union symbol in the interval notation. And then y greater than or equal to 2 is bracket 2, comma, infinity. This is the interval notation. Let's go ahead and sketch a graph of the solution. So if we plot the points negative 1/2 and 2, then this part of the number line from negative infinity up to negative 1/2, we have a bracket at negative 1/2 and shade to the left. On the left here is where negative infinity is. And then on the right, 2 to infinity, including 2, so we put a bracket at 2, shade to the right. Okay, I hope going over those absolute value inequalities helps. You will see those again on test 1 and probably also on the final exam. Okay, we have a few minutes. Let's look at some other things that we didn't get to. We did do this one already in a past class session. The directions are determine, there's a word missing, determine which of the ordered pairs are solutions to the equation 5x plus 9y equals 4. We did this first one the way that you do it. Since this ordered pair has an x coordinate of 7 and a y coordinate of negative 31/9, what you do is you replace x with 7, replace y with negative 31/9. If the resulting equation is true, then that ordered pair is a solution. So a few days ago, we discovered that this ordered pair is a solution. Remember that the number of solutions to a linear equation in 2 variables, there are infinitely many solutions. So just because we found a solution doesn't tell us anything about the other ordered pairs. The other ordered pairs may or may not be solutions. So let's test negative 10, negative 7, negative 10, negative 7. So in the equation, 5x plus 9y equals 4, replace x with negative 10 and replace y with negative 7 and check to see what happens. So we have 5 times x is negative 10 plus 9 times negative 7 equals 4. Well, this doesn't look very good for that ordered pair. 5 times negative 10 is negative 50 plus 9 times negative 7 is plus negative 63. So it's pretty evident that this is false. The left-hand side simplifies to negative 113, but that is certainly not equal to 4. So the ordered pair negative 10, negative 7 is not a solution. Then the next ordered pair, 5 for x and negative 7/3 for y. So in the equation, 5x plus 9y equals 4, replace x with 5, so we get 5 times 5, and then plus 9 times negative 7/3, and then do the arithmetic. 5 times 5 is 25, and then plus, well, let's multiply 9 times negative 7/3 the easy way. You can think of 9 as 9 over 1. 3 goes into 3 once, and 3 goes into 9 3 times. So we're going to add 3 over 1 times negative 7 over 1, or we're going to add negative 21. And 25 plus negative 21 equals 4. That is true. So another way to write 25 plus negative 21 is to write it as 25 minus 21. Okay, so this ordered pair, 5, negative 7/3, is a solution. Okay, one more. Let's test 0, 10. So this time replace x with 0. We get 5 times 0 plus 9 times 10 equals 4. 5 times 0 is 0. 90 equals 4. That's false. So none of those, or that, I should say, this ordered pair is not a solution. Okay, we can graph these two equations in the next couple of minutes. Graph the equation 4x plus 2y equals 2 to start with. After today, we have more options for graphing equations. We can always use the x and y intercepts. So we have infinitely many choices. We just need to find 2 ordered pairs. So if we pick x to be 0, then we get 4 times 0 plus 2y equals 2, or 2y equals 2, so y equals 1. So what is the ordered pair 0, 1? What's the name for that? The name for that point on the graph is the Y-intercept, because the x-coordinate is 0. So this is the Y-intercept, because every Y-intercept has an x-coordinate of 0. And then if we pick y to be 0, in the equation, we get 4x plus 2 times 0 equals 2. 4x equals 2, so x equals 1/2. So this ordered pair, 1/2, 0, since the y-coordinate is 0, this is the x-intercept. Okay, then we can plot those 2 points and draw the graph. 0, 1 is on the y-axis. So 0, 1 is the y-intercept. 1/2, 0 is the x-intercept, 1/2, 0. And then draw a straight line to those. Okay, so it's about time to quit. Tomorrow we'll be in the next section. What section? 3.2 is what we'll be in tomorrow. Tomorrow will be more about lines, straight lines. Okay, but that's all for today.